So I'm going to go through these density problems and explain a little bit about density and review key things that you need to remember when you're doing these problems. So first of all, the most important thing is the formula, obviously. So density equals mass over volume. It's a little broken heart. So for this first problem, it says what is the density of CO gas if I'm dealing with grams, this is going to be my mass, and the 100 milliliters is my volume. And so I start out, density, which I'm trying to solve for, equals my mass, which is 0.196 grams divided by 100 mils. Okay? And so if you do that in your calculator, what you'll get is 0.00196, so 0.00196, and remember, since you're taking mass and dividing it by volume, it's just your units are just grams over mils. Now, the first thing I have to worry about is actually sig figs after my units. And so if you notice, both of these things are being estimated, both the mass and the volume. So this only has one sig fig. This is 3, and so since I'm dividing, I'm doing based on sig figs. My final answer, therefore, needs only 1. So my answer is going to be 0.002, because the 1 rounded up, grams per mil. Don't add more zeros or else I'll make it incorrect. All right, for the next problem, a block of wood. So one side is 3 centimeters. Okay, since it's a block, we can assume it's a cube, right? So little cube, very cute. So to find the volume of this, it's going to be length times width times height, which are all 3. So 3 times 3 times 3, which is 9. Now, unit-wise, since I multiplied centimeter by centimeter by centimeter, this is going to be 9 centimeters cubed. Okay. The mass is 27 grams. So based on the formula, I'm going to take 27 grams, divide it by 9 centimeters cubed. And what I get is 3 grams per centimeter cubed. Now, sig fig-wise, what you should be doing, because when you start working with the numbers, you might be messing up sig figs without realizing it, just go back to the original problem. This has 1 sig fig, this has 2, so my final answer needs 1, which this has, so we're good to go. An irregularly shaped stone was lowered into a graduated cylinder holding a volume of water. So it started out with a volume of 2 mils. So this is just like the lab we did. Here's the initial volume. Here's the final volume after you added the stone. So the purpose of this is if you have a funky shape and can't do length times width times height, what you can do is say, okay, the volume of the water was initially 2 mils. Now it's 7 once I added the stone to it. Therefore, that tells me that the volume of the stone has to be 5 mils because it displaced that much water. So that's a really nice, easy way of finding the volume of a weirdly shaped object. So that's what we did in the lab. Now, I know that the mass of the stone is 25 grams, so all I have to do now for density is 25 grams divided by 5 mils, and that will give me 5 grams per mil. Now, sig fig wise, 25 has 2 sig figs, 5 has 1 sig fig, so I'm good to go. All right. Last problem. I tell you that the volume of copper is 10.0 centimeters cubed. And also that the mass, so this is mass, is 89.6. This is the volume. So all you have to do, then again, mass divided by volume. So it's going to be 89, no point there, sorry, 0.6 divided by 10.0. And so what you'll get is 8.96. Now, sig fig wise, 8.96 is going to be grams over centimeters cubed. Okay. Sig fig wise, 89.6 has 3 sig figs. 10.0 actually has 3, 1, 2, 3. And so this is perfect for my final answer. So what I'm going to do right now is give you two different other types of problems that I could give you for density. Because in these cases, I've just given you mass and volume and asked you to solve, which is pretty dang easy. What if I made it a little bit harder? What if I gave you density, okay, so let's say, I'm just making this up, I told you that the density of something was, I don't know, 15 grams over centimeters cubed. Oops. And I also told you that the, I don't know, volume is 3 centimeters cubed. And I want you to find mass. So let's solve it. So density equals mass over volume, and you just plug in the values that you know. So density is 15. Okay. Volume is 3, so I put volume on bottom and mass up top. Now, you can just multiply both sides by 3, guys, and you'll get the correct answer. However, I just like to be careful and put this over 1. I always just cross multiply in my head. So 1 times m is m. 15 times 3 is 45. My units, since the units for density are grams over centimeters cubed, volume is centimeters cubed, the units for my mass are going to be grams. The only thing you need to be careful with this problem, this has 2 sig figs, this has 1, so my final answer needs 1, so this is going to be 50 grams. Okay, so really not that bad, not that much math required. Let's try a problem where a little bit more math skills are required. So what if I'm asking for volume? So I give you the density equals, I don't know, let's keep the same thing, 15 grams centimeter cubed, but this time I tell you that your mass is 3 grams. And I want to know what your volume is. So what you're going to do, again, plug and chug. Your formula, always write your formula, your broken heart first. Okay. My density is 15. My mass is 3. I'm trying to solve for volume. And so what you're going to end up having to do, you're going to cross multiply. So 1 times 3 is 3 equals 15 times V. Divide both sides by 15. Okay. And 3 divided by 15 is 0.2. That's my volume. Now, unit-wise, let's figure this out. So my volume is 0.2, mass is grams, density is grams, the other unit is centimeters cubed, so that will be my volume unit, so 0.2 centimeters cubed. Okay. This has 1 sig fig, this has 2, so this needs 1 sig fig. However, if I gave you, I don't know, 3.0, and you needed 2 sig figs, but I got 0.2. Don't just throw your hands up in the air. All you have to do is take 0.2, add a 0 to the end. Now you've got 2 sig figs, and you're good to go. And that's it. So these are 2 ways that I could switch the problems up on you. Okay? You'll be fine as long as you write the formula and plug in what you know.